Hello future professionals, welcome to day 28 of our top 100 coding question analysis. Today we are challenged with the question to find the prime factors of a given number. Now that our problem statement is defined, let's have a hands-on experience of solving the problem. Before we start finding the prime factors of a number, let's look at what are prime numbers. Prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, so on, right? But what is a prime number? Prime number are numbers which have only two factors, right? That are 1 and itself, right? If you still don't know what is a prime number, we have made a video previously. I'll give the link to it, which you can find in the top right corner, so that you can get an idea of what is prime number and then continue with this video. Now that we have understood what is a prime number, let's look at the method with which we find the prime factors of a given number. This method is not new for any one of us because we have used this in our childhood, where our teacher gives the number as 12, okay, and asks us to find the prime factors of the number 12, right, using prime factorization method. Prime factorization. So we wait till the teacher solves the problem. Now the teacher inputs the number as 12 and she puts 2 as the number because we know 2 is the least prime number, correct? And she also knows that 2 exactly divides 12, right? So the remainder is 0. Next, she reduces 12 by 2, that is, she divides 12 by 2 and gets the answer as 6. Now we divide 6 by 2 because teacher knows that when 2 divides 6, it leaves the remainder 0. So 2 is also a factor of 6, right? Then she reduces 6 by 2, that is, she divides 6 by 2 and gets the quotient as 3. Now she knows that 2 does not divide 3 completely, so she moves to the next prime number, that is 3. As we see, 3 is the next prime number, right? So when she divides 3 by 3, she gets the remainder as 0. So 3 is a factor and the quotient is 1. Now the teacher does not further divide this because 1 is neither prime nor composite, right? Next, now the teacher challenges us with a difficult problem. She gives 24, right? As usual, we wait for the teacher to solve, but this time teacher does not solve but asks any one of the student in the class to solve, and we shall wait until the boy or girl solves the problem in the board so that we can copy it before the end of the period, right? So let's see how the child solves the question. Now the child has put 24 as the number and divides it by 2 because the child knows that when 2 divides 24, it leaves the remainder 0. So 2 is a factor. Then the child reduces 24 by 2, that is, it divides 24 by 2 and gets the quotient as 12, right? Again the child divides it by 2 and it gets the quotient as 6. Again by 2, we get the quotient as 3. Whatever the child writes here is a factor, right? Next, it knows that 3 is not divisible by 2, so it moves on to the second prime factor, that is 3, right? Now it divides and it gets the value 1, that is the quotient. So, and the child stops here because 1 is neither prime nor composite. Now the teacher asks the other student to come to the board and write the prime factors of the number. The other child goes and writes it is 2 into 2 into 2 into 3. Right? This is how we find the prime factors of a given number. Correct? Now that we have got the hands-on experience of solving the problem, let's look at the logic to solve this problem. The logic is that first we shall get the number from the user. We divide the number by the least prime number, that is 2. Okay, divide it by 2. If it is a factor, if 2 is a factor, we shall include 2 in the factors list, right? Third is we reduce the number by the factor. For now it is 2, right? And store it in the number variable itself. Right, that is nothing but n. Now, fourth step is that until the number is greater than the least prime number, that is greater than 2, right? We check for prime factors. Okay. Once this condition is not satisfied, then we print the prime factors list. Right? Then we terminate the program. Now that we have looked at the logic of how to solve the problem, let's implement it by coding our program. Let's now look at the code. First, we have defined a getUserInput function where we get the number from the user and store it in the n variable. Next, we return the n variable. The second function we have defined as prime factors, where it gets the parameter as num. Next, within this function, we initialize a factors list variable to an empty list and the factor variable to the least prime number, that is 2. Next, we use a while loop to check whether the number is greater than or equal to 2, because in prime factorization we only reduce the number until the number is greater than or equal to 2. Next, we check whether when the number is divided by the factor gives the remainder as 0. If it gives the remainder as 0, we conclude that factor is a factor of the number. Then we append the value in the factor variable to the factors list. Next, we reduce the number by the factor and store it in the num variable itself. If when the number is divided by the factor does not give the remainder as 0, then we increment the factor by 1. When this condition fails, we come out of this loop and next we return the factors list. Now that we have understood both the functions, let's call the functions. I call the getUserInput function and store the return value in the num variable. Next, I call the prime factors function by passing the num variable within a print statement. Right? Now let's run the program and look at the output. Let me input 12 as the number. I get 2, 2, 3 as the output. Let me enter 24 as the number. I get 2, 2, 2 and 3 as the number. Thus, we have successfully completed our program. I hope you would have got the best out of this video. I recommend you to subscribe our channel to get more such interesting videos. I also recommend you to like and share the videos if you find it supportive and interesting.